Hello, this video we're going to go through the notes here, hopefully explain a lot of what's occurring here in this section. We're going to get to the problems tomorrow and do some sample problems from the section, but this of course is the background you're going to need. Anyway, last section we were only dealing with discrete probability distributions. Now in this section we're dealing with normal, which are continuous. In other words, your results don't have to be just numbers of whole people. They could be, anything like a decimal, 12.2, 12.5, 21.999, things like that. As a result, your distribution then becomes a normal curve or a bell-shaped curve. There's a few things you have to keep in mind here with that curve here. Mean, median, and mode must all be the same number right smack dab in the middle of your curve. It's bell-shaped, symmetric about the mean, so left hand looks the same as right. Before, all your probabilities for your results had to add up to be 1. Same thing here. Even though you've got decimals for each little one of these, that total area underneath the curve has to equal 1 as well. We're going to use that extensively. Okay, of course, the normal curve expands out, but it never touches the horizontal axis. And then, okay, just as a matter of symmetry for the curve, as you can see, the curve is downward facing from the mean to plus or minus 1 standard deviation. If you go past that, both below 1 standard deviation, above 1 standard deviation, it faces upwards, so therefore you have inflection points. Again, we saw this one before. Don't worry so much about that little equation there. You won't be using that too much. Okay, what happens here? Obviously, your inflection points change. Okay, here the means are just different, but that's not a big idea. The big idea here is with the standard deviations. As you notice in this curve, it's spread out a little more, so your inflection points are further away from your mean. For this one here, which one has the greater mean? Obviously, it's the one on the right. B has the greater mean. The other one is 5. This one's 9. Which one has a greater standard deviation? Okay, well, it's B. Obviously, it's more spread out, so it has a greater standard deviation. Again, you can use this kind of idea here to graph out various examples here, magnolia bushes. You can pretty much pick off the standard deviation from the graph and the mean from the graph. You're going to have to do that for a few homework problems tomorrow. Next up, this is a big idea here. We're going to use this one extensively. A z-score is essentially the value of the standard deviation away from your mean. So I have to give you the mean and standard deviation. If I give you a value, then you can figure out that value minus the mean divided by the standard deviation. Gives you a z-score. If you don't remember, a couple months ago, I showed you the tables in the back of the book. Well, that's what that is for. We're going to go to those tomorrow and do a whole lot of examples from that. Don't worry so much about this. Okay, this is kind of important, though. Please realize, okay, if you go past 3.5 standard deviations, either above or below, essentially there's no probability. The probability is 0 underneath that curve. Past those points, okay, your z-score, as it increases, the area underneath the curve is increasing. As you move to the right, you'll see some examples for that tomorrow. Z is, of course, 0 for the mean. Okay, so your probability at that point is always 0.500. Again, area underneath the curve is 1, and as you get close to this upper cutoff, 3.5, positive 3.5, your area will be close to 1. Anyway, here's a shot of the tables. We'll be dealing with these a lot tomorrow. I'll show you how to work these. Here's a good little primer on that, so if you can't follow me tomorrow, maybe you can follow from there. Realize a z-score, okay, in this case it's 1.23, gives you everything up to that point, that 1.23. So what's the probability of you getting up to the mean plus 1.23 standard deviations? It's 0.8907. What's this? Okay, this one's a little tutorial on how to find the probability past that. So for example, if we went to 1.23, what's the probability of everything to the right? Well, your table will give you to the left, 1 minus the area to the left gives you the area to the right. So 1 minus that 0.8907 gives you the area past 1.23, which is 0.1093. To find the values between, you'd simply find the one value, subtract the other probability. Here they want to find this, the area to the left of negative 2.33. Well, you just look up in your back, your textbook, negative 2.33. The area to the left is 0.0099. And they go to 4 digits. There are some tables that go to 5, but you only have to go to 4. How do you find the area to the right? Again, you find how much is to the left. In this case, it's 0.8264, and then 1 minus that gives you the area to the right. To find the area between two z-scores, okay, well, what you do is you find the higher probability, 0.8577, subtract the lower area, which is 0.0239, that gives you 0.8339. Again, we'll work on some sample problems tomorrow. Please look this over, digest this. The sample problems are pretty simple, but it would help if you had the ideas down. Copyright Steve Anderson, 2020.